All right, let's jump right into this explainer. Look, if you follow modern physics at all, you probably know the frustration, right? We've got these incredibly successful models, but man, they are just tangled up with loose ends. We're talking dozens of unexplained parameters, the invisible ghosts of dark matter and dark energy, and of course, that constant friction between quantum mechanics and general relativity. Well, today we're unpacking something fascinating. It's a deeply ambitious proposed mathematical framework called foundational substrate theory, or just FST. And honestly, this paper attempts the ultimate physics magic trick. It tries to wipe the slate completely clean and derive our entire universe, essentially, from scratch.
So here's our roadmap for the explainer. We'll kick things off with the physics parameter crisis, then introduce foundational substrate theory itself. After that, we'll hit the law of zero, the layered multiverse, how this resolves some massive cosmic mysteries, and finally, how we can actually test this theory.
Okay, starting right off with Section 1, the physics parameter crisis and why we have way too many loose ends.
32. That's a pretty wild number, because it's roughly the amount of unexplained, experimentally measured parameters that our current models, like the standard model of particle physics and our best cosmological models, basically rely on just to function. We're talking about things like particle masses, coupling constants, dark energy density. And look, we know these numbers work, phenomenologically speaking, but the theories themselves, they cannot explain why they are what they are. They're basically just empirical inputs. It's almost like they're cheat codes we have to plug into the universe's code base just to make the math actually work out.
Now, contrast that whole mess with this number, 8. Foundational substrate theory is proposing a total paradigm shift here. It wants to take those 32 totally unexplained parameters and boil them down to just 8. The authors claim that from these 8 fundamental inputs alone, literally every single other physical parameter in the universe can be uniquely determined. 0 free adjustable parameters left over. How crazy is that?
Which brings us to Section 2, foundational substrate theory, and our cosmic building blocks.
So, what exactly is this foundational substrate? Well, FST posits that there's this dynamic, omnipresent, pre-geometric field, and everything, all matter, energy, space-time itself, emerges from it. And to dictate how this substrate behaves, the theory relies on these exact 8 inputs. It starts off with pure mathematical necessities, right? Euler's number, pi, the square root of 2. Then it folds in established physical constants, like the speed of light and the Planck constant. Finally, it uses 2 strictly empirical realities, the fine structure constant and the proton-electron mass ratio. But I want you to look closely at input number 4, because that one is the true engine of this entire theory.
That would be the strain parameter, clocking in at roughly 0.05. Now in FST, this is definitely not just some random number. It actually represents the intrinsic curvature, or essentially the warping, of the substrate itself. The authors are proposing that if the substrate were perfectly flat, like if this parameter was exactly 0, every single excitation in the universe would be completely massless. So it's exactly this 5% warp that introduces a whole hierarchy of scales, and literally gives birth to the mass of particles as we know them today.
Moving into Section 3, the law of zero, and how this theory balances the cosmic equation.
Okay, so with the substrate established, how does FST govern the actual creation of matter? Well, it relies on a very strict universal balance. The idea is that whenever an excitation creates standard matter, the regular stuff with positive mass and positive energy that makes up you, me, and all the stars, it has to simultaneously create what they call complementary matter. And actually, let me be super clear here. This is not antimatter. Complementary matter possesses literally negative mass and negative energy. The absolutely crucial point here is that they emerge together to ensure that the total net energy of the entire universe always remains exactly at 0.
Now, I know exactly what you're probably thinking. If half of all the matter generated in the universe is this negative, complementary matter, where in the world is it? Why can't we see it? And for that matter, why doesn't it just cancel everything out?
And this right here brilliantly illustrates how the theory tackles one of astronomy's absolute biggest headaches. FST proposes that complementary matter extends outward from standard matter in this vast, sprawling density profile. Basically, it acts as a massive halo that only interacts indirectly with our regular matter. According to the math laid out in the paper, this extended, invisible halo of negative energy generates the exact same gravitational effects that we currently attribute to dark matter. It solves the missing mass problem simply by balancing the universal equation. Kind of elegant, right?
All right, Section 4, the layered multiverse, or as I like to think of it, peeling the cosmic onion.
Now that we've seen how FST handles things on a microscopic scale, and even out to galactic halos, let's zoom all the way out to the grandest, honestly most staggering claim of the entire paper. Based on the horizon factor that they derive from those substrate dynamics, the authors calculate that our observable universe, it's not the totality of existence, not even close. It's actually just one single layer in a vast cosmic onion. Surrounding us are these massive outer layers, and beneath us are inner layers, each with completely different density and velocity profiles. And the sheer scale of this is just mind-bending. FST calculates the total radius of this layered universe to be 10 to the 61st power times larger than what we can currently observe.
But that obviously begs the question, why can't we see these other layers? The paper uses a truly fantastic analogy to explain this. Because the different layers have different phase velocities, they end up creating these refractive indexes right at their boundaries. Think of a swimmer underwater who's looking up at the surface. At a certain angle, that surface acts exactly like a mirror because of total internal reflection. In the exact same way, light from the outer layers of this multiverse is physically trapped. It literally cannot penetrate the refractive barrier to get into our observable layer.
Which takes us to Section 5, Resolving Cosmic Mysteries, specifically dark energy.
So this massive, layered structure isn't just cool world building for the sake of it, it actually mathematically tackles another massive headache for physicists. The cosmological constant problem is basically the mystery of why dark energy is 120 orders of magnitude smaller than what quantum mechanics predicts it should be. It is notoriously known as the worst prediction in all of physics. Well, FST argues that the dark energy we observe isn't just the vacuum energy of our single layer, but the integrated effect of all those layers combined. Because the substrate has a fractal dimension, which calculates out to an effective dimension of roughly 1.9, and because our observable horizon is just so impossibly tiny compared to the whole thing, the energy is heavily suppressed. The math literally spits out a suppression factor of 10 to the negative 120, completely resolving the discrepancy. Bam.
Finally, Section 6, Testing the Theory, because we have to go beyond the math.
Look, of course, a mathematical framework is just elegant philosophy until it actually makes contact with physical reality, right? How do we prove or disprove these absolutely mind-bending claims? Well, FST actually makes several highly specific falsifiable predictions. For instance, based purely on that 5% strain parameter we talked about, it predicts the exact mass of a sterile neutrino to be 25.5 kiloelectron volts. Current experimental bounds allow for a super wide range, but next-generation tests happening right between 2025 and 2030 will be able to check that exact value. It also predicts a very specific suppression in the cosmic microwave background at small scales, which the Simons Observatory is gearing up to test very soon. So if these highly specific numbers fail to materialize in the lab, the whole theory falls apart. It's testable, which is exactly what you want.
Ultimately, foundational substrate theory is an incredibly ambitious attempt to unify physics without relying on arbitrary numbers. By reframing reality as this geometrically warped, beautifully layered structure, it offers real mathematical solutions to dark matter, dark energy, and the very origin of mass itself. But it also leaves us with a profound, almost dizzying realization. If everything we have ever observed or will ever observe is just light trapped inside one tiny layer of a cosmic onion, what lies beyond the very edge of the substrate itself? That is a question to take with you today. Thanks for joining me on this explainer, and keep your curiosity focused.